Here we have a NEMA DC-3 thermostat test chamber that we're doing final inspections on before shipping out. I'll just walk you through the operation of this really fast. First of all, we use Yokogawa temperature controllers to maintain very tight temperature control. It's currently coming down from a very high temperature soak to verify operation. For each of the thermostat loads, you can individually set the load current of each load, such as the fan circuit, the heat loads, or the cooling contactors. You can adjust the test voltage that's actually running the thermostat. We're going to keep it around 28. And this is the total current passing through the thermostat right now. So to set the current, press this button, and the load current reads out up top, for which you adjust it. And we'll adjust it down to 1 amp. And that's close enough. So now you can see we're back down to 2 amps because this load is turned off. Inside the temperature chamber, we've just temporarily rigged a thermostat, but we put the thermal sensor directly in front of it, along with an airflow sensor. And all wiring comes out the bottom of the mounting board. The mounting board simulates a room wall that's typical to a house. And of course we have a inner door so that you can open and see the thermostat reading without interrupting the airflow or the temperature in the box. Of course, everything's well insulated, all stainless steel inside. Just a quick view of the back of the unit with one of the panels removed. You can see the inner thermal chamber, which is all stainless steel, as mentioned before. There's a drip tube for condensate out of the bottom. A couple of air intakes for the compressor, and the ability to add external loads so that you can run a full line voltage, line current thermostat in the chamber without any worries about the voltage or the current. I do believe this particular unit can take up to 50 amps. Here's the chamber running at 35 degrees. As you can see, a very flat line. And here's the chamber running at 100 degrees Fahrenheit. Also, very stable, flat line. Notice there's a slight discrepancy between the overtemp controller and the temperature controller. That's because they're in two different locations. To operate a test, which the box is currently coming down from 100 degrees, we've added a thermostat, and we're going to select to run 19 and 20 from the profiles, which are both cooling tests. We'll go to operation. We load the run information, which puts it at the top, and we'll start the test. Its current set point is going to be at 70 degrees because that's what we've set the soak temperature to, which you can see at the top. Once it reaches 70 degrees, it'll soak for 120 minutes, and we'll start the test. So we're now approaching the very end of our soak period of our test. You can see the temperature's at 70 degrees. Very stable, flat line, with the exception of where I open the door once or twice. We have a very short time left on our soak. And as soon as we come out of soak, since we're in cool mode, the target temperature will start to drop at the rate that we determined in the test, which will be 4 degrees per hour up, 6 degrees per hour down. You can see those numbers just changed. Let's scroll over using the touch screen. And our first test is for a duration of 4 cycles, 4 degrees up, 6 degrees down per hour. So if we look at our temperature controller, it is now dropping at 6 degrees per hour. If we come back and visit our test, you'll be able to see if the thermostat operates correctly, a triangle wave of sorts that'll show the on and off position of where the thermostat turns on. You can see currently we have cooling is on and the fan loader on, and so that's why we're currently cooling the chamber. Here you can see we're several hours into this cooling test. Temperature's dropping. You can clearly see the pickup and dropout temperatures displayed on the screen. The yellow line is the cooling load and the green line is temperature. You can see the average pickup and dropout temperatures, and it's their test averages. It shows the percent changes. You can see we're 5.5 cycles in to the test, which is 14.04 hours. And you can see how smooth the temperature transitions are. There's really not much overshoot. Really tight temperature control. And once our test is completed, we just simply turn off the box and remove the thermostat. The easiest way to do that is to turn the compressor off, heaters, and blowers. Now the box is sitting here in a live state, but it's not consuming very much energy at this point. You can remove the thermostat and prepare for the next test.